Again with MIA Microflight, and this is the C189. As I have shown in my other videos, customized with some upgrades. It was flying great earlier today. I had some great flights during the late afternoon, where to the point even that this was flying hands off the transmitter. It was so stable. So I had a little confidence that this was going to fly okay. I charged my battery, and later on at night I tried to fly this, and I had a mishap once again. You know, that sinking feeling that you get, that gut feeling that you know that it's going to get away from you. It happened. I just had that gut feeling that you know it wasn't going to perform as well for some reason. And sure enough, it started to lift and lift, and I could not use the throttle to bring it back, so I had to use my emergency stop button. Luckily, I modified my transmitter with this button on the back, where I can just hit it with this finger right here, because I hold the radio. You know, obviously you got to hold the radio, but your finger just sits perfectly right there, so it's a lot easier than using this guy right here. So I hit that, and luckily I was able to catch this helicopter. Minor scratch on one of the blades, I think, but I ended up breaking some of these couple of these little pegs that support the canopy. Anyway, while I was opening this up, and I was thinking maybe it's a power issue that I'm having. Maybe it's not delivering proper 5 volts, you know, to the receiver. I took the receiver, I removed the receiver, and I showed the receiver in just a little while ago, which is what I want to concentrate on. But in the process of researching for the specs on these MOSFETs, while at it, I found that the MOSFETs they're using here are actually 100 amp MOSFETs. 30 volt 100 amp MOSFETs are the ones that are used for this for the main motor. That's way overkill for a motor that's not going to pull more than, I don't think this motor pulls more than 10 amps, worst case scenario. But they're using 100 amp MOSFETs, which is, you know, like I said, overkill. But they probably get these MOSFETs just as cheap as maybe the 15 amp ones. So while I'm doing that, I stumble on some information regarding some threads that discuss the same issues that I've been having with this helicopter regarding the barometer sensor that is on the flight controller. Now, this is the power distribution board. It's got, you know, the incoming connection to the battery. Battery connects here. It distributes the proper voltage of typically 5 volts, you know, to the sensors and the flight controller, and also distributes has the control for the speed control for the motors, basically the ESCs. So that's a power distribution board, and I ended up taking this one completely off the board in order to analyze this and see if there was maybe a crack on the PC board or something that was acting up, that was intermittent. I believe, I really believe this is just just by looking at this and inspecting this this board right here that has the sensor. The barometer sensor is this little device here that's on this square foam frame. The sensor is directly underneath there. Is that little chip right there? Is that the sensor? The senses changes in pressure, and so that's what keeps it you know, at a certain altitude, and it keeps measuring. Basically, it measures pressure sensitivity. That thing right there is has this this type of connector, this flexible connector, and when I was removing this, I wanted to see where the sensor was, because I wasn't sure where the sensor was. I figured it was underneath somewhere, but I didn't think it was underneath this board here. But that's where it is, and the foam is there just to keep this floating. You very keep vibrations at minimal. I noticed that this connector here, if my camera can capture that, this has a what looks like a hairline fracture on the, where's my I need some kind of a pointer here. This has a hairline, what appears to be a hairline fracture on right there at that neck where it becomes a V as part of this connector here. So I believe that that one of these connectors may be intermittent, and the sensor is probably sensing correctly. But if this is if there's a hairline crack there, that it's not getting the right signals here. Now there are one, two, three, four, five five signals here that are connected to the flight controller here. So this sensor right here is connected to the flight controller, which is this part of this receiver also that also has the connections for the servos and the LEDs. So this is the flight controller. And this is the barometer sensor that's got this is the PC board for the barometer sensor that sits underneath here, and this right here, this flexible PC board connector, or well, it's not a PC board, but it's a flexible connector. Just looking at with my magnifying glass, I don't know if my camera will catch that even with if I use my magnifying glass here. Probably not, because let's see. If I can get it to focus right there. I almost had it. Okay, it just using my magnifier here and looking at this, I'm going to have to put it under the microscope. I do have an electronic microscope that I can see with a much better resolution. If indeed this is a hairline crack on the board, I put a continuity meter between each one of these leads, because this also connects to the. Come on, baby. Connects to the board here. Let me move this gently here, because I don't. I'm gonna have to rewire that, because I don't trust that flexible connector. So, if there's an issue with that, which I think it is, because I also see that there's a bend there. That's how the helicopter came. So whoever was assembling this probably handled that. And if you flex that too much, you're going to develop a crack, because these things are very sensitive. I've had a similar experience with a crack. Hairline fractures on similar connectors for LCD displays, where they use these connectors. And if from handling, bending it or removing it, if you're not really super careful, you're gonna introduce a hairline crack, and it's not gonna have connectivity in some or all the leads that are part of that connector. So I believe that is the issue with these helicopters, that I think that these things may be mishandled. They're not handled properly, and so because this connector is so thin at that neck right there, mine, I think it has a hairline fracture there that it's not. Because it's erratic. Sometimes it works perfectly and sometimes it doesn't. So I think vibrations maybe may disturb that connection that's kind of floating, barely making a connection perhaps. So that's my logic with this. I did put, like I said, I have my voltmeter set to continuity, so that I can test point to point, and I was able to get continuity, but I'm going to have to kind of fix my tester, or my test leads on these points right here. I'm going to have to maybe solder some external leads connected to the meter, so that I can gently try to flex this at the same time, because I'm working with my hands, so I can't do that. All this testing without these connections being a little more permanent there. So I'm just holding my test leads, and I think if they're more permanent, I can try to flex this a little bit and see if there's any if it's erratic, or if there's a loss of connection there. So that'll tell me for sure that this connector is good or bad. But I suspect that this hairline fracture, that little hairline fracture, which is it happens in these connectors very often. So it's nothing it's a problem with these types of connectors. So I suspect that that's what the problem is with this with my helicopter. That it's because this is what actually is doing the throttle changes for you. The via the flight controller's computer. It's doing that to start the heli to raise it to a certain height and maintain that height. And if that's erratic, and when you go to throttle up, that's gonna throw it off, and you're just not gonna have the control. So that is my take. I hope I am on the right track here. But that would be my analogy here. Just using just basic common sense, logic here. Just based on my experience with this particular helicopter, and just based on some of the things that I read. None of the stuff that I came across mentions the possibility of this connector having hairline fractures. So maybe this is the first video. I don't know. I like I said, I just came across some threads. Apparently, RC groups and Heli Freak forums have more information on these, but I think there are more of people that have been just removing this completely and installing rotor flight controllers and programming, via rotor flight that way. So you have more precise and more secure setups than these things are, the way these are set up and done. But I don't want to go that route. I mean, I was ready to do that with one of the flight controllers that I have, an F4, I think it is, or according to Rotorflight, you can use F4, F7 flight controllers that have at minimum 15 amp ESCs. But I don't want to go that route yet until I'm absolutely sure that I know the cause of this issue here with these controllers. It's got to be the sensor over here, because this is what's doing the control for you. And if that gets out of whack, you're going to see it in lack of throttle and in lack of control of the helicopter. This would also act up, whenever I start my cyclic controlling, when I'm trying to correct for deviation in position of the helicopter would be at the cyclic. So I think that's introducing vibrations, and I'm almost certain at this point that it's a hairline fracture. Now that I said that, so that's where I'm at. The solution to this would be to wire directly point to point from here using some very, very thin wire. I do have that wire here. What size wire is this? I don't even know what size this wire is, but this is also it's not stranded wire. It's just a single copper solid wire. So but at least it'll, I can have a little more reassurance that this can also be done with some very, very thin silicone wire, stranded wire. Just being careful, to make sure that none of the contacts are shorted, going from that to that, and having a little loop there, so this has some suspension as well. That's the reason why they're using these types of connectors, because you also have suspension that's very lightweight, so it doesn't hinder the vibration isolation features that you want on this barometer. That's the reason why they're using this foam frame here underneath around that chip. So anyway, that's my take on this. I am going to spend some time until I discover, what not discover, until I do these. I'm just going to change it and see if the helicopter flies better with no issues on the sensor. But I at this point I am almost certain that it's that, because there's when I first opened this, I noticed that there's like a V when you fold, like a piece of paper that you fold, and it has a crease. It's got a crease on the neck. On the neck of that connector there, and we can probably see it in this video. Yeah, there's a crease there. So when they install this board, I suspect that they bent that, and or whoever's doing this at the factory, maybe they're not careful. So that could be a major issue here with this, because the sensor is what's doing the sensing. So I suspect that that's what it is. Mario, once again with MI Micro Flight. Stay tuned for more.